Okay, so we are good to go. Let's begin. So we are in the last part of real numbers. So this is the last day of unit number 1. So we took more than enough time for this lesson because this is a pretty small lesson. Yet we dragged it a bit to get the nuances, to get the idea of everything inside the lesson. So last week we were talking about surds. Surds are the, so I hope you remember, surds are the square roots of non-perfect squares, right? Surds are the square roots of non-perfect squares. So if I write 2 examples, no, I'll write 3 examples. Out of these, I just number them 1, 2, and 3. Out of these, you have to select the surds. Try selecting the surds. This is just a recap. Right? Try selecting the surds out of these 3. Yeah, 1. Is it only 1? Exactly. It's 1 and 3, right? Yeah, it's 1 and 3. Because the number 3 is not a perfect square, so it doesn't have a root. Doesn't have a perfect root. But number 36 has a perfect root. What is the square root of perfect? Sorry, what is the square root of 36? Yes, the square root of 36 is 6. So this cannot be a surd. These two are surds. Okay. And I'll ask you another question. Are surds rational or irrational? Of course, surds are irrational. That's why we are representing them as the square root. We do not decimalize them. We only keep it that way. This is the final result. This is the final way of representing a surd. Representing the square root of an unperfect square. Okay. So that's why they are called surds. And then we were talking about entire surds. We talked about entire surds. So entire surds mean numbers. Okay, out of these 3, like we know now this is not a surd. Is there any entire surd out among these 2? If there is, what is it? What is the entire surd? If there is an entire surd. Yeah. The entire surd among these 2. Yeah, there is an entire surd among these 2. The entire surd is the square root of 20. So we were talking last week what are entire surds. I'll explain you again. Entire surds can be simplified further, which means this one cannot be further simplified because this is a prime number. 3 is just 3. 3 is 1 times 3. We cannot further simplify. But 20, we can write in many ways. 20 can be written as 2 times 10. How else can we write 20? As factors. How else? Yeah, 4 times 5. 4 times 5. So can you see? I can write 20 as 2 times 10, or else 4 times 5. So here, I have a square number. This one is not valid for entire surd. For making it a surd, I can write it like this. In case, like, if I get a square number, I can take the square number out. So, 4 times 5, if I take 4 out, we know it becomes 2. The square root of 4 is 2. So, the final answer would be 2 root 5. This is the surd form of the entire surd 20. So, 20 is an entire surd. So, entire surds are basically surds which have perfect squares inside. We have to find the perfect square and take them out to simplify them. Exactly. So these are what we learned in last week. So today we are going to learn third operations. Last week did we learn third operations? I hope not. There are 5 third operations. Okay. I'll just start with the last two, fourth and fifth one. Those are addition and subtraction. Addition and subtraction of surds. So these are similar to fractions. For example, like consider root 2 plus root 2. We can add them. What's the meaning of entire surds? Okay, I'll repeat. Did you get the meaning of entire surds when I explained it? Or else should I repeat? Okay, I'll repeat. Wait. Entire surd means, so this is a surd now. Root 3 is a surd. And also root 6. This is also a surd. But 6 can be written as 2 times 3. Even if we write this as 2 times 3, there is no use because both of them are non-perfect squares. So I can't take any number out. I can't take any number out from this root. Do you get it? So this is just a surd. This is a surd. This is also a surd. Right. The square root of, let's say, the square root of 50. If I write the square root of 50, I can write 50 as 25 times 2. No? Now what can I do? I can take this 25 out. So it becomes 5. 5 root 2. It becomes 5 root 2. So now the surds which can be simplified like this, the surds which have hidden squares inside them are known as entire surds. These are not entire surds, but this is an entire surd. Now is it clear? Oh, good. So we were talking about surd operations, and the first operation is addition. So here's root 2 and root 2. So some people might think if we add these two, we'll get root 4, and then the answer would be 2. Right? And then the answer would be 2. But this is totally wrong. We cannot add surds with it. And like I'll explain you why. I'll tell you why. You very well know that this is an irrational number. And this is also an irrational number. We talked about irrational numbers in the first 2 days. And we did true or false questions. And if you can remember, there was a question. If we add 2 irrational numbers, the result will be definitely an irrational number. If we add 2, so if we add 2 irrational numbers, the result will definitely be an irrational number. But yes, we add 2 irrational numbers and the result becomes rational. This is not possible, right? This is not possible. So this is wrong. This is totally wrong. So how do we add these two? How do we add this? It's like this. Consider this as an unknown because we do not know the value of root 2. No? We do not know the exact value of root 2. So we consider this to be an unknown x. Consider this to be an unknown x. The same thing now. What is x plus x? In algebra, what is x plus x? Yeah. Yeah, x plus x is 2x. So root 2 plus root 2 is 2 root 2. I hope that is clear. Exactly, 2 root 2. So if they give you, let's consider root 2 plus another root 2 plus another root 2, which means this is something similar to x plus x plus x. So this doesn't become root 6. This is x plus x, which means 3x. 3 root 2. Is that clear? Yeah. Okay. And then if they give you something like this, root 2 plus 7 root 2, what would be the answer? Root 2 plus 7 root would be the answer. Yeah, 8 root 2 because this is something like x plus 7x. Na? So we know from the small edges, x plus 7x is 8x. So 8 root 2. I hope that is clear. Yeah. Okay. All right. Now let's come to this. Look at this example. Root 2 plus root 3. I'm asking you a quick question. Can we add these two? Can we add these two? Exactly. We cannot add because we cannot even add the like cells. The similar ones we cannot make 4. So there's no way we can add these two. Like root 2 plus root 3 doesn't become root 5. You very well know that. So I proved it to you. Two irrational numbers cannot be added in a general way. Correct? So this cannot be added. This is like x plus y. No, these are different. No? X plus y. So the result is this. This is the final answer. This cannot be further simplified because these sets are called unlike sets. These sets are called unlike sets. But these are called like sets. See, these are like sets because the irrational part is the same. No matter the number, the irrational part is the same. So these are like sets. In like fractions, the denominators are same. So we can add. Same like that. In like sets, the irrational number, the root is the same. So we can add. I hope it is clear. It's not a big deal, right? Okay. The subtraction is done in the same way. I'll just give you a quick question for addition. And let's see how far you are okay with it. Root 2 plus 3 root 3 plus 3 root 2 plus minus root 3. You guys take your time, solve this, and send the answer in the chat box. Okay, there's one answer. To do this, okay, let's see. To do this, first we have to check the like search. We definitely cannot add these two. We can't add these two. The reason is here the irrational part is 2, here the irrational part is 3. So it's something like this. I'll take root 2 as x and root 3 as y. You don't have to do this. Just for the sake of understanding, I'm teaching you like this. Right? See, here's x. Here is 3y. See, 3 root 3, 3y. Here's 3x. Here's minus y. Now I hope it is clear. See, x plus 3x is 4x, no? So, root 2 plus 3 root 2 would be 4 root 2. Same like x plus 3x is 4x. Root 2 plus 3 root 2 is 4 root 2. You know, 4 root. Is this clear? This step? I hope it is okay. And then 3y minus y is 2y. No? Likewise, 3 root 3 minus root 3 is 3 root 3's and here 1 root 3. So 3 minus 1 is 2. 2 root 3. So if we solve this, we'll get 4x, 4x plus 2y. Same like that. If we solve this, you'll get 4 root 2 plus 2 root 3. I hope it is clear. If it is not clear, just let me know. I'll repeat. Okay. And then we are done with addition, like addition and subtraction both were there. Okay. The second line. Which one? This one. This one, right? Okay. Let's see. That I did like this. See? Root 2, here's 3 root. See, first you have to choose, you have to pick which ones you can add. See, this root 2 cannot be added with this. This root 2 can be added only with this 3 root 2. Is that clear? Because the third is the same. Here the third is different. Third is 3. So you can't add these two. This is like x and this is like 3x. So you can add these. X plus 3x is 4x. Same like that. Root 2 plus 3 root 2 would be 4 root 2. Is that clear? These are okay. The blue color ones, the same are like cells. Here simplified. Okay. And then root 3 stuff. See, this can be added with this because the interior, the third part is the same. So there are 3 root 3s and here 1 root 3. You have to subtract. So if you subtract 3 from 1, like if you subtract 3y from 1y, sorry, if you subtract 1y from 3y, the answer is 2y, right? So 3 minus 1 is 2. Same like that. 3 root 3 minus root 3 is 2 root 3. Is that clear? Yeah, good. So this is how you add and subtract cells. So multiplication and division is pretty easy, easier than addition and subtraction. So first, take your tube, and in the tube, see the first few questions. Those are easy. So I'm not gonna give you a lot of time to do those. You can say the answers at once. See, the first question is in page number 10. I'm talking about page number 10, question number 19. The first question, 3 root 5 plus 5 root 5. So we all know that. What is the answer? 3 root 5 plus 5 root 5 is 8 root 5. So we do not add these. We only add the numbers in front. We do not add the surds. Right? So there is 8 root 5. Similar to that, there's the next question. 5 root 3 minus 3 root 3. 5 root 3 minus 3 root 3. So what is the answer? What is 5 root 3 minus 3 root 3? Yeah? Yeah, that's correct. So 5 root 3 minus 3 root 3 is. So like I said, don't try to simplify these. You only simplify the numbers in front. 5 minus 3 is. Very good. Okay. So these are pretty basic questions. So I need you to attempt a question like the third one, Roman number 3. See, this is also easy, but you'll have to figure out. Try doing this. I'll give you around 3 minutes. Give it a try. Give it a try. I'll give you 3 minutes. Yeah, Anjali, your answer is correct. You can try the rest. You can try the 4th, 5th, and the 12th questions, 4, 5, and 12. You can try them. And there's a small correction in the 5th question. Roman number 5. Roman number 5, there's a small correction. This must be root 12. This is not just 12 in Roman number 5. Everyone just correct it. It is root 12. And those who have done this, one person has done. So others, if you did this, send me the answer. If you couldn't, just let me know. I'll explain. So what about the others? Shall we discuss the question on the board? Okay. So here the goal is to make the irrational parts equal, because can we add these two? We cannot add because these are not like surds, no? Not yet. Because see, here is root 20, here is root 5. So we cannot add. So if this is root 5 and root 5, I can. Or else if this is 2 root 5 and root 5, could be added. But here the irrational part is 20, here the irrational part is 5. But we know this can be converted, this can be simplified, because this is what? This is an entire circle. This can be further simplified as, we did this in the beginning of the session, 20 can be written as 4 times 5. Right? This thing I'll just write it at 5. Now you can see that, yeah, I can take this 5, sorry, I can take this 4 out. So I took 4 out, it becomes 2, right? 2 root 5 plus root 5. And see, the irrational part became equal. So always, if they give you a question to add or subtract, the irrational part becomes equal. And then you can add the irrational parts. 2 root 5 plus root 5 is 3 root 5. So simple, right? Simple. Is this clear for the rest of you? For those who didn't do that? Is it clear now? Yeah, good. So you can try the fourth question, Roman number 4. Try it. Give it a try. Roman number 4. Good. 4 root 3 minus root 12. So that is Roman number 4. You can give it a try. 4 root 3 minus root 12. Fine. Exactly. The answer for the fourth one is 2 root 3, right? Yeah. So, easy enough. 4 root 3. I'll just keep it as 4 root 3. 12 can be simplified. 12 can be written as 4 times 3. 4 times 3. Always we have to check, we have to factorize it with the root inside. So it is root 3. So I must divide 12 by 3. So 12 by 3 is 4. 4 times 3 is 12. So that is the easiest way. 4 root 3. Here 4 comes out. So it is 2. 4 root 3 minus 2 root. 4 root 3 minus 2 root 3 is 2 root 3. So that is the answer. Okay, for the final, like you can do the rest of them in like in your free time. Just I'll explain the fifth one. The fifth one. root 12 plus 3 root 75. The same way. So here both are not like, this is not, these are not like cells. So what we do is, first 75 is a factor, not a multiple of 12. So I cannot write this as 12 times something. So I must factorize both of them. 12 we know how to factorize already. 12 is 4 root 3. 12 is 4 times 3. Okay. There's a 3. Don't bother, don't bother about this 3. It is there. 75. So see, 3 will be remaining here. So 75 I have to write it multiple of 3. So 3 times 25 is 75. 3 times 25. And now if I took the 4 out, this is 2 root 3. And here the 3 just exists. The 3 is there. 25, if we took out, it becomes 5. Right? So when a number goes outside, it basically gets multiplied by the number existing number, right? Okay. Here's 2 root 3. 2 root 3 plus 15 root 3, which is 17 root 3. Is it clear? Is it clear? Yeah. Great. So finally, I need you to do question number 12. Question number 12. And then we can move on to the next two operations. Right? Do that alone. Question number 12. That's the last question on page 11. Root 99 plus root 11 minus root 44. This is it. Try doing that. Anjali, you can try question number 13 and 14. Yeah, when a surd is not simplified, it is called an entire surd. For example, this is an entire surd. This is also an entire surd. But when it transforms, like it has been simplified. Now it is not an entire surd. This is just a surd. Alright? So here it is an entire surd. Once we simplify it, it becomes a surd. Okay, I'm getting answers. That's good. 3, 4, 2. Yeah, 2 root 11, right? 2 root 11. So that doesn't need a big explanation. I'll give it. So 99. So everything is a multiple of 11. It's visible, right? 99 is 9 times 11. 11 is just 11. 44 is 4 times 11. If you took 9 out, that is 3 root 11. If you took 4 out, that is 2 root 11. So 3 root 11 plus root 11 is 4 root 11 minus 2 root 11. 4 minus 2 is 2. The final answer would be 2 root 11. Okay. Yeah. So that's it. We are good to go. Yeah. As a final question, let's do the 13th one. 13, question number 13. Root 18 plus root 50 minus root 32. Not right? Give it a try. Okay, I have got one answer. Okay, two answers. Let's see. Everything here is an entire set. All three sets are entire set. And we know in order to make perfect squares, this is 9 times 2. So you can understand that 9 goes out and 2 remains. So I'm going to factor everything by 2. I'm going to write everything as a factor of, as a multiple of 2. So here's 2 times 9. 50 is 2 times 25. 36 is 2 times 16. So you can see that everything here is a perfect square except 2. So you take 9 out, it's 3. You take 25 out, it's 5. You take 16 out, it's 4. 3 plus 5 is 8. 3 plus 5 is 8. So this is 8 root 2 minus 4 root 2. 8 root 2 minus 4 root 2. 8 minus 4 is 4 root. Final answer is 4 root 2. So that is clear. Now let's move on to the next topic, like next operation on surd. So the next one is, the next two are multiplication and division. But before that, I'm gonna give you this operation, right? Root a into root a. So this is pretty basic. This is general rule. What do you think happens here? What would be the value of this? Root 2 times root 2. Yeah, root 2 times root 2 is 2, because we know we cannot add irrational numbers. We cannot add. Addition is prohibited. But we can multiply. In real numbers, we learn, like in the first part of real numbers, in true or false questions, we learn if you multiply two irrational numbers, sometimes the answer could be rational. See? So we can multiply. 2 times 2 is 4 now. So basically this gives us root 4. What is the square root of 4? The square root of 4 is 2. The square root of 4 is 2. I'll take another example. Root 3 times root 3. So that is square root of 9. So 3 times 3 is 9. The square root of 9 is 3. Root 7 times root 7. 7 times 7 is 49. The square root of 49 is again 7. Root 10 times root 10. So that is 100. The square root of 100 is 10. So you guys are seeing a pattern here, na? Like just ignore the middle step. If you ignore the middle step, you can see that if you multiply an irrational number, like if you multiply a surd by the same surd, what happens? The root gets removed. The root gets removed. Root 3 times root 3 is just 3. Root 7 times root 7 is just 7. Root 10 times root 10 is just 10. Makes sense, right? Because this gets squared. So the opposite of square is the square root. Same like addition and subtraction getting cancelled. The square and the square root gets cancelled. So here, root a times root a. What would be root a times root a? Yeah, that's easy. What is root a times root a? That's just a, right? The square root of a times the square root of a. The answer is a. The square root of any number. The square root of x times the square root of x gives us x. The square root gets removed. Right? It is not x squared, right? It's just x, because it becomes x squared, the square root. The square and the square root gets cancelled. So the final answer is just x. Pretty easy now, right? Yeah. So this is the first operation. This must be taught first, but I went into addition and subtraction. That's not a problem. Now let's come into multiplication and division. So multiplication and division. Multiplication, let's say square root of 3 times square root of 2. Here we can multiply, because you know in fractions, even in fractions, even if the denominators are not same, you can multiply. Only addition and subtraction have the rule to make the fractions like fractions. In surds, that is the same way. In order to add or subtract, you have to make the irrational part equal. See? But in order to multiply, that's not a must. Root 3 times root 2 is root 6. Is that clear? Just 3 times 2, 6. Is that okay? I hope it is. Yeah. Root 2 times root 5. That is 2 times 5, 10. Don't forget the root. Root 10. Right? And let's see, 2 root 3 times 4 root 4. Oh, sorry, not 4. That is right, 4 root 5. Huh? Yeah, that is root 6. Here you have to be a bit careful. You can only multiply the surd with the surd, the number with the number, the whole number with the whole number, and the surd separate. Right? So the whole numbers, if you see, 2 times 4 is 8. 8 is in outside, yeah. And the surds, 3 times 5, 3 times 5 is 15. That is 8 root 15. If you understood this properly, you can do any multiplication. That's never going to be a problem for you. Right? You multiply the numbers separately, you multiply the surds separately. Final answer is root 6. Yeah. In this one, the final answer is root 6 because root 6 cannot be further simplified. This is not an entire surd. This is surd. Here also, the final answer is root 10. Yeah. Clear, na? Good. So, there can be some questions like this. 2 root 3 times 5 root 3. Here it's going to be a bit of a problem. See, 2 times 5, 2 times 5 is 10. Now you very well know what is root 3 times root 3. What is root 3 times root 3? Yeah, you can write it as root 9, or else we know if we multiply the same number, the root gets removed. Na? The root gets removed. So it's just 3. 10 times 3. The answer is 30. The root gets removed. The reason we are multiplying the same number. We are multiplying the same number. Is it clear? Yes, great. Good. Okay. Give me a minute. Okay, now I'm visible and audible, right? I was getting a call. Yeah, okay. So these are how they're gonna give you multiplication questions. Multiplication. Now let's move on to division, the final operation, division. So division, I'll just give you some divisions like this. 4 root 15 divided by 2 root 5. Huh? So the best way to do divisions is you have to write this as a fraction. 4 root 15 divided by 4 root 15 divided by 2 root 5. Right? So this is the easiest way. So there could be other ways, like you can divide 4 by 2 and you can divide these two separately and you can do the answer. But the most effective way is this. The easiest and the effective way is this because they won't only give 2. They will give a lot of like numbers to simplify. Okay? Let's say here, before simplifying, I'm going to do another correction. Like you can simplify in this stage, right? This is all we are good to simplify here, but for further safety, I'm gonna like combine these roots because both of them are inside roots, so I can combine. The roots. Now outside the root, that is 4 divided by 2, so we can cancel if you need. That's just 2. inside the root, that is 15 divided by 5. 15 divided by 5 is 3. The final answer is 2 root 3. Is that clear? Okay. So as an example, I'm going to do the 36th question in the table. It is on page number 14. Page number 14. Right? The 36th question. 36th question. That is 3 root 5 times, 3 root 15 times 2 root 22 divided by 7 root 2 times 165. This is called 165. So like I said, see, they do not give you only 2. They have, like, not like this. They give you a lot, right? So the best thing, like I said, take the numbers, take the whole numbers separately. 3 times 2 and in below that's 7, right? See the whole numbers. And then take the roots separately. 15 and then there's 22 on the numerator and in the denominator that is 160. Right? I hope that is clear what I just did here. Right? Now, if you look at the outside, the whole numbers, there's nothing to cancel. So we just multiply 3 times 2 is 6. And there's this 7. But inside, there's plenty to simplify. Here 15 times 1 and 165 is 15 times 11. 165 is 15 times 11. Or else you can cancel these from 5 and then from 3, no matter. And then, can you see again, 22 and 11? 22 and 11 can be simplified. So 22, that's 1. Sorry, 11, that's 1. 22, that's 2. So inside the root, there's no denominator. The denominator is 1. The numerator is 2. Is this clear? So best way, take the whole numbers away. Take the surds alone. Is this clear? If it is clear, you can try doing the questions I mark on the board. Right? On page number 13, you can try the 22nd question. 22nd means double x, double I. 22nd one. And then you can try the 24th one. And then you can try the 25th one. You can try question number 27. And then on page number 40, you can try 2 questions, that is 35 and 38, 35 and 37. I'll give you some time. Try these questions. Try these questions and send the answers one by one. So when typing the answers, you don't have to like type the Roman numbers, just write 22 and the answer, right? In 7 root 2, where did that 2 go? Oh, I'm sorry. I missed a 2 here, right? Yeah, I did note that. So, like, I'm sorry, here there must be another 2 no? Inside the square. Thanks for noting it. There's 2, so this 2 gets cancelled with this 2, no? So the like this square root part that gets cancelled because everything is cancelled. So inside there's 1. So the square root of 1 is just 1. So the final answer is 6 over root 7. Thanks for noting that. I'm sorry, I just missed the 2. Okay, if you're done with the answers, you can send them. Give me 1 minute. I'll be back. You can send the answers in the chat. I'm going to mute myself for a minute. Okay, good. I'm getting answers. I'll give you a few minutes more. Okay. Do you need more time or shall we discuss? What about it? It's okay. Like, just send them. No problem if they are wrong. That's not a problem. Right. Okay, let's discuss. Let's see. Question number 22, right? Let's start with 22. That is 3 root 2. 3 root 2 times 2 root 3. 3 root 2 times 2 root 3. So here, let's see. 3 times 2. Right? Here, what do? We simplify, we multiply the whole number separately and we multiply the surd separately. 3 times 2 is 6 and inside 2 times 3 is also 6. So the answer is 6 root 6. That's the answer for the first question. And next, what did I ask you to do? 24. 24. 24, I'll just do it here. Twenty-four. See, 3 root 14 times root 35. So here you can do 14 times 35 and then yeah. Or else I can do something like this. So for my easiness, I'm doing like this. 14 is 2 times 7 now. 14 is 2 times 7. And then it can be further multiplied by 35. 35 is 7 times 5. 7 times 5. Now can you see that? Here 7 times 7, 49. 7 times 7 is 49. That's a square number. So I'm going to take the square number outside. So if I took 49 outside, I'll end up with 7. So on the inside, there would be 2 and 5. That is 10. So here it's 21 root 10. So if you are not okay with this step, what can you do? You can multiply 14 by 35 and then you can come to an answer. I'll do that also. So what? 3 root 14 times root 35 now. So what did I teach you? You simplify the whole number separately. So the whole numbers are only 3 and 1. So just 3. 14 times 35 you have to multiply. That gives you 490. 490. So 490 is 49 times 10. 490 means 49 times 10. So we know like 49 is uh, 49 is a square number. Square number. So we do 49 now. That is 3 times 7. Okay. So 3 times 7 is 21. 21 root 10. Okay. All right. And then I'll just clear this. Okay. And the next question, that's pretty easy. The question number 25. See, that is 7 over root 8. Sorry, root 7 over 8 into root 8 over 7. I told you we can combine the roots if it is multiplication and division. So I'm going to combine the roots. I'm going to write this inside one root. So what happens? 7 and 7 gets cancelled. Now 8 and 8 get cancelled. So what remains inside this root? Tell me the correct answer. So if everything gets cancelled, 7 divided by 7 is 1, 8 divided by 8 is 1. So yeah, inside 1 remains. So what is the square root of 1? The square root of 1 is 1. So the answer is 1. The final answer is 1. Final answer is 1. Okay. And then I have asked you to do 27. 27 is 2 root 15 into 3 root 5. The same thing, you can do it this way. That would be easier. See, what I'm going to do is 2 root 15 is 5 times 3. 15 is 5 times 3. And then, like, I'll just simplify the 2 and 3 first. 2 and 3. 2 and 3 is 6. 2 and 3 is 6. 15 I can write 5 times 3 because there's another 5 here. Now 5 and 5, 25. I can take them out. So 6. If I took 25 out, I'll end up with 5. 6 times 5 is 30. That is 30 root. 30 root. Is that clear? So the answer for the 35th one, no, the answer for the 27th one is 30 root 3. And let's see the 35th. The 35th. So the 35th is the same like the 36, just we did that. Okay, 35th. I'll just explain the 35th here. Right. 2 root 3 into 3 root 6 over 4 root 2. So now take the whole number separate. The whole numbers I'm going to take separately. 2 times 3 and in the denominator there's a 4. These are whole numbers now. And take the third separately inside a common rule. 3 times 6 divided by 2. 3 times 6 divided by 2. Now we can simplify these. 2, there's 1 2 in 2 and there's 2 2's in 4. So the final answer is 3 over 2. 3 over 2, right? So within the square root, can you see that? 6 and 2 can be cancelled. 1 and 3. Within the square root there is 9. 3 and 3 is 9. So what is the square root of 9? The square root of 9 is 3. So I don't have to write the root anymore. I can write it as 3. So the final answer would be 9 over 2. So yeah, another question, right? Yeah, 9 over 2. So this is not like we can't keep this because what kind of a fraction is this? You guys tell me. What kind of fraction is this? Yeah, that is improper. So improper fractions cannot be kept as constants. So what we do is we make it into a mixed number or a mixed fraction. Right? How many 2's are there in 9? There are 4 2's. 2 times 4 is 8. 1 remains. So we put the remainder in the numerator and the denominator doesn't change. This is a mixed number. This is the final answer for the 35th question. And then after the 35th, did I give anything after the 35th? I have erased the board. Did I ask you to do the 37th one? 37th one? Yeah. So it's 37th one, right? Yeah. 37. Let's do the 37th one here. Yeah. Let's see. 2 root 45 times 3 root 20 times 4 root 18 over root 6 times 5 root 27 times root 240. See, it may seem like a hard sum because there are a lot of numbers and all, but it's not a big deal. Here it's not visible, right? It is light. That's 3 root 20. I'll just write it below. Right? So, yeah. The same steps. Write the whole numbers separately. 2 times, 3 times 4. Right? 2, 3, and 4. And below there's 5. There's just 5, no? 5. And write the third separately inside a common root. 45 times 20 times 18 over 6 times 27 times 240. 240. Now let's simplify. There's nothing to cancel here. So I'll just multiply 2 times 3 is 6. 6 times 4 is 24 over 5. 24 over 5. Let's see here. I can cancel these zeros. And then I can cancel 6 times 1 and 6 times 3 is 18. Huh? And then I can do 3 and 27. There's 1 3 in 3. And there's 9 3's in 27. 9 times 3 is 20. Huh? And then I can further cancel 9 and 45. There's 1 9 Here's 5 nines. And then further, see, 24 and 2. 2 and 24 can be cancelled. As 1, how many 2's in 24? 12 2's. See, a lot of numbers can be cancelled. So almost everything is cancelled except 5. So inside the root there is 5. And in the denominator there's only 12. Right? So the final answer is 24 over 5 into 5 over 12. So if you need, you can keep this as a like mixed fraction. So if you turn this into a mixed fraction, you will end up with 4 and 4/5 multiplied by 5 over 12 is the final answer. Is the final answer. We can further wait. We can take a 2 out of here, no? In 12, see 24 over 5, right? I can write 12 as 3 times 4 now. So I can take this 4 out now. If you took this 4 out, it will come as 2, right? It come as 2. So you can cancel this 2 and 24. Right? Yeah, we can cancel that 2 and 24. So the final answer would be 12 over 5 root 5 over 3. So now you can make this a mixed fraction. 12 over 5 as a mixed fraction is 2 and 2 over 5. And within the root, there's 5 over 3. That's it. Is this clear? So this is by far the like hardest. We can't say hardest. This is not hard, but this is by far the most time-consuming question we did for today. Right? Great. Okay. Now, no, that's not needed. This thing, you don't have to make it a mixed fraction. Even this, you don't have to make it a mixed fraction because this is associated with a third number. So that's not necessary. If there's only the fraction that is improper, then you can make it a mixed fraction. This is not necessary. Even though I did, that is not necessary. You can keep it as 12. Right? Okay. So that's it for multiplication, division, addition, and subtraction. Now, I'm going to give you like a grade 10 sum. I'm going to give you a grade 10 question. Let's see if you can do it. Try simplifying these brackets. Try simplifying these brackets and give me an answer. Okay, that's not a problem. Explain you how to do it. Okay, so in questions of this type, right? So these are called binomials. The reason they are called binomial is they have two terms. Okay? 2x is one term, y is one term. So this is a binomial. A is one term, 3b is one term. So these are binomials. Yeah, I have an answer. Let's see. In these kind of questions, you have to choose a bracket first. I'll choose this bracket, this bracket. So from 2x, I'm going to multiply these two. Right? From 2x, I'm going to multiply this a and 3. So 2x times a is 2xa. 2xa, or else I can write 2ax. The order doesn't matter. Right? 2x times a is 2ax. Is this clear? The first term. Huh? And then, again, I'm going to multiply 2x from 3b now. When multiplying, we multiply the numbers separately and the letters separately. 2 times 3 is 6. 2 times 3 is 6. X times b is xb. X times b is xb, or else bx. Or else b, xb or bx. Doesn't matter. So now the job of 2x is done because I multiplied this by both the letters. Now I'm going to do the same thing for y. I'm going to multiply y by this and by this. So y times a is ya or else ay. Like I said, the order of letters doesn't matter. Your method was correct. Great. Okay, good. So and then y times 3b is 3yb or else 3by. 3by. So this is the final answer now because we cannot simplify further. Like here's bx, here's ax, we can add bx and ax. If this is also bx, then we can add. But here we can't. So this is the final answer. Right? So the reason I gave you this is for you to understand this. If they ask, if they give you some sort of, let's see, questions like this, a question like this. Okay. So this is the final. Yeah, this is the final. Okay. So here we are going to do the same thing we did here. What? The same thing. Only the only difference is here that's letters and here it's numbers. Right? Now let's see. From 2, I'm going to multiply these two. From root 2, I'm going to multiply root 2 times root 7. So there's root 14. You get it? Root 2 times root 7 is root 14. 2 times 7 is 14 now. Root 2 times root 5. That is root 10. Root 10. Now the job of root 2 is done. Now from root 3. Root 3 times root 7 is root 21. Root 3 times root 5 is root 15. So we cannot further simplify because none of them are entire surds. Everything is a surd. We cannot further simplify these and take square numbers out. Nothing. So this is the final answer. Is this understood? Yeah. Now, let's say something of this sort. Root 2 plus root 3 squared. Root 2 plus root 3 squared means, I'll take another one. Root 5 plus root 3. Root 5 plus root 3 squared. Which means the meaning of square is what? We have to multiply this again by this. So root 5 plus root 3 multiplied by root 5 plus root 3. So now you know how to do it. Now the same way. But there's a catch. So from 5, I'm going to multiply these two. Now think carefully and tell me what is root 5 into root 5? What is root 5 times root 5? Exactly. Root 5 times root 5 is 5. Root 5 times root 5 is root 25, which is 5. Root 5 times root 5 is root 25. But we learned root a times root a is a. Na? So root 5 times root 5 is 5. The square root of 25 is 5. So now we don't have to write the square root anymore. Root 5 times root 5 is just 5. The number 5. And then the next one, root 5 times root 3. 5 times 3 is 15. So that's root 15. We have to write the root. And then the job of 5 is done. Now 3. Root 3 times root 5. That is also root 15. root 15. And then finally, root 3 times root 3. What is root 3 times root 3? Root 3 times root 3 is 3. Now, can you see that these are just two numbers? We can add numbers. So 5 and 3 is 8. 5 and 3 is 8. Normal addition. Root 15, we know x plus x is 2x. Same like that, root 15 plus root 15 is 2 root 15. 2 root 15. Is this clear? Yes, great. So I'm going to give you two questions of this sort. In page number 14, right? Page number 14, question, the last two questions. In page number 14, question number 38, and question number 39. These two. Those are similar to these. Huh? Try doing them. I'll give you 5 to 10 minutes. It won't take that long. Huh? You can look at them and you can try this. Right? We have the root, right? The questions anyway. Root 2 times root 2 plus root 7. And then root 2 plus root 3. So no matter, you don't have to be afraid of getting the answers wrong. Just give it a try. Trying is the thing. You have to try. Okay. I'll mute myself so you can try them. Okay, so these are pretty simple ones, no? See, root 5 times root 2, like from root 5 and multiply these two. Root 5 times root 2 is root 10. Root 5 times root 7 is root 35. And from this, these two. Root 3 times root 2 is root 6. Root 3 times root 7 is root 21. So the next thing, root 2 plus root. Root 2 times root 2. Root 2 times root 2 is 2. Root 2 times root 3 is root 6. 2 times 3 is 6. So the job of root 2 is done. Now root 3. Root 3 times root 2 is again root 6. Root 3 times root 3 is 3. Root 3 times root 3 is 3. Now we can add these. 2 plus 3 is 5. 5 plus 2 root 6. It is the final answer. Okay. Yeah, good. No problem. So this is what I wanted to explain to you. So we are almost at the end. We almost finished the lesson. There's one last topic. So that's super important, right? So before going into the topic, I want to give you a small note. It's not exactly a note, that's a small sentence that can be written in the last page. So in the last page, there's notes. There's a space for notes. If you do not have a printed copy, it's okay. You can write it in your book or anywhere. The topic is conjugates. The word is conjugates. So conjugates, what do conjugates mean? Conjugates mean, I'll explain it to you simply. If there's an expression like A and B, so these are applied to binomials, right? So if there's an expression as A plus B, the conjugate of A plus B is A minus B. The conjugate of A plus B is A minus B. If there's an expression called A minus B, the conjugate of A minus B is A plus B. Yeah, like we can't use the word opposite. The reason why we can't use the word opposite is, for example, if there's A plus B, the opposite of this would be minus A minus B. Because both of them are plus, no? Both of them are plus. If you say opposite, that means minus A minus B. Conjugate is a bit different. Yeah, conjugate is a bit different. They only change the sign in the middle, not the sign in the beginning, only the sign in the middle. Right? So that's the difference between the opposite and the conjugate. So conjugate is basically A plus B, the conjugate of A plus B, same answer. Right? So we can write a note. I'll just type it here. I'll read it the same time I'm typing. Yeah. When the sign in the middle of a binomial expression is inverted or changed, when the sign in the middle of a binomial expression is inverted, it generates the conjugate of the original expression. So, for example, you can write the conjugate of A plus B is A minus B. Example, you can write the conjugate of A plus B is A minus B. So if you have the printed copy of the tube, you can write it in the last page where I have left to write notes. I hope it's clear here. Yeah, notes. So if you haven't, that's not a problem. You can write it in your book or somewhere. So why we learn conjugates? So you will see why we learn conjugates in a while. So I'll explain you the reason. Mostly we are multiplying two conjugates, and in grade 10 you might have heard this word, difference of two squares. Have you heard difference of two squares? Yeah, difference of two squares. Yeah. So difference of two square means basically a difference of two squares expression is generated by multiplying the conjugates. See, if we multiply a times a is a square, a times b is plus ab. Now his job is done. Now b times a is also ab, but here it is minus and plus. No, minus and plus means it's minus ab. And then b times b is b squared. Here also minus and plus, so it's minus. So can you see AB to AB gets cancelled? AB to AB gets cancelled. So it means it is A square minus B square. So the meaning of difference of two squares you might already know. Difference means subtraction, not sum. Difference. Sum mean addition. Difference means subtraction. Subtraction. Here are two square values. So these two square values are subtracted. That's the meaning of difference of two squares. So any numbers, any two expressions which are conjugates, for example, m plus n, m minus n, right? If you multiply them, you will end up with m square minus n square. You don't have to go on simplifying like this. You can directly use this in an exam. M plus n multiplied by m minus n means m square minus n square, right? So for example, a plus b, a minus b means a square minus b square. Always the middle is minus. That's why it's called a difference. I hope this is understood. This is a grade 10 part. This is grade 10. Right? So, if I write 7 minus 2 and root 7 minus root 2 and root 7 plus root 2. So these are conjugates, right? If I multiply these conjugates, I'll end up with root 7 square minus root 2 square. So we know square and square root gets cancelled now. So root 7 square is just 7 minus root 2 square is just 2. The final answer is 5. The final answer is 5. Yeah. Okay. Is that clear? Yeah. So we normally use conjugates for multiplication. Now you can turn to the page number 15, and there's a question on page number 15. If you need, you can just note this down. This is difference of two squares. On the 15th page, the first two questions are root 3 minus root 2 multiplied by root 3 plus root 2. So the answer would be root 3 square minus root 2 square. Right? The square root of the square of square root 3 is just 3. The square of 2 is just 2. Square of root 2 is just 2. So which means the answer is 1. Did you understand this? Is this clear? Okay. So what would be the answer for the next one? Root 6 plus root 5 and root 6 minus root 5. What would be the answer for that? So you just have to put 6 and 5 here. No? The square root of root 6. The square of root 6 is just 6. The square of root 5 is just 5. No? Like root 6 square is root 36. No, root 36 is 6. Root 25 is 5. Root 6 minus root 6 squared. Like here it's root 6 minus root 5. Root 6 plus root 5. No? So which means root 6 squared minus root 5 squared. Root 6 squared is like 6 squared is 36. The square root of 36 is. So we can directly put root 6 squared is 6. Root 5 squared is 5. 6 minus 5 is again 1. You know. That's clear. Okay. Now, like I said, we are coming to the last topic of our lesson. This is the very last topic, and then we are done with real numbers. It took us quite a long time. The last topic is rationalizing the denominator. Rationalizing the denominator. Okay. So rationalizing the denominator means in a fraction, let's see, this is the fraction. Huh? Let's say this is the fraction. This is the fraction. So in the fraction, this denominator, is this rational or irrational? The denominator. The denominator is irrational. Q dash is the denominator is irrational. So these kind of fractions are hard to solve. So what do? We make the denominator rational. How to make it rational? Let's see. Right? You might have done this at school already. So before moving on to this, I'm going to ask you two questions. There's a fraction like this, and there's a fraction like this. Right? Two fractions, ma'am. Huh? This here, I'll write it here. So this is one fraction, and this is another fraction. So you can see that those are not the same fraction, right? And I'll give you the value of root 2. The value of root 2 is nearly this 1.414. We know this doesn't end. This doesn't end. This keeps on going. So I just stop at 1.414. Now I'm asking you, you can put this value instead of root 2. You can put this value instead of root 2 and solve these fractions. You can get a decimal number. Which fraction would you prefer? Which fraction would be easy? Which fraction would be easy for you to solve? The first one or the second one? Or both are the same difficulty? What do you say? Take your time and think well. Either the first or the second. Which one would you prefer? Okay. I have an answer. Yeah. The easiest fraction would be the second one. I'll tell you why. So in the first one, if I put 1.414 instead of root 2, and in the second one, I'm going to put 1.414 instead of root 2. So this is the first fraction and this is the second fraction. No? Can't we take square root 2, the denominator up and make it 2 squared? Square root 2, no, it doesn't work that way. So in the second unit in grade 11, you are learning indices and logarithms. So in that unit, we can take this roots up. But even taking the powers up doesn't help in this case. Right? I'll explain you how to do this. So here, this is a division of 2 divided by 1.414. This is 1.414 divided by 2. So if you wrote it inside the division box, this is like this. 2 divided by 1.414 and here 1.414 divided by 2. So in order to perform this division, you need to know the multiples of 2. We already know the multiples of 2. That's pretty easy. No? So we can easily do this division. There are no 2's in 1. So we take 0 and we borrow this for here. So how we put a decimal point. And how many 2's are in 14? That's 7. And again, no 2's in 1, 0, and again 7. So this is pretty easy because you know the multiples of 2. But do you know the multiples of 1.414? Do you know them? The multiples of 1.414? No, that takes time because the first part you could do. Inside 2, there's only 1.412. Right? But after that, it gets complex. So the mathematicians, what do? They do not prefer square roots being in the denominator. Numerator, no problem. You saw that now? Numerator, if there's a square root, no problem. If there's an irrational number in the numerator, it's okay. We can somehow simplify that. But if it is in the denominator, that's the case. So what do they have? What have they introduced? They have introduced the method of rationalizing the denominator. It's a very simple method. What we do is, see, this is an irrational denominator. So what you do is you just multiply this fraction, you make it an equivalent fraction, you multiply this fraction by a number to make this rational. I'm asking, you are open to answer. What number should I multiply this with to make it rational? You very well know that now. Which number should be multiplied by root 2 to make it rational, to make it to remove the square root? Yeah, if you multiply root 2 by the same thing, if you multiply root 2 by root 2, right, the square root gets removed. But in fractions, we know we can't do only for the denominator. We must do the same thing for the numerator to make it equivalent, right? Now you see root 2 times root 2. What is the answer? Root 2 times root 2 is, yeah, exactly. Root 2 times root 2 is 2. So root 2 times root 2 is root 4. In turn, it gives us 2. 2. 1 times root 2 is just root 2. Now, yeah. Now is the denominator rational or irrational? Now the denominator is, yeah, now it is rational. See, now it is rational. The denominator was once irrational, so we made it rational with just a multiplication, right? So, is this clear? Is this clear? This is the final topic, rationalizing the denominator. Is this clear? Good. So I'll do two more examples and I'll give you some questions, right? Do an example 5 over root 3. 5 over root 3. So this is an irrational denominator. The numerator, no problem. Even there's, let's say root 5, even there's root 5 in the numerator, that's not a problem. Right? We only have to look at the denominator. So from which number should we multiply this? From which number should we multiply this fraction? Exactly. We have to multiply this fraction with root 3. Root 3. We don't care about the numerator. We only look at the numerator. So root 3 times root 3, we very well know that that is 3. Root 5 times root 3, you know you can multiply inside the root. 5 times 3 is 15. That's the square root of 15. So this is the final answer. The numerator, the denominator has been rationalized. Huh? Let's do some more. Let's do let's do 6 over root 3. 6 over root 3 multiplied by just 6 over root 3. So what is the number you suggest? Yeah, we multiply again by root 3, exactly. So root 3, root 3, root 3. 6 times root 3 is 6 root 3. We can see this is not the same as this. This is root 5 into root 3. This is not 5 into root 3. This is not root 6. Just 6 into root 3. 6 into root 3 is 6 root 3. No? Root 3 into root 3 is just 3. But this doesn't end here because we can cancel these two. No? 3 plus 1 3 in 3 plus 2 3s in 6. So the final answer is 2 root 3. Is this clear? Good, great. So this is the final example I'm going to do, and I'm going to give you some questions from the tutor, right? Let's see. Let's do. What are you going to do? Let's do this. 5 over 3 root 5. 5 over 3 root 5. So from which number should I multiply this fraction? Yeah, we have to take only the surd, root 5. So we have to remove that surd. So we multiply it by root 5. Root 5. 5 times root 5 we know it's 5 root 5. 3. The 3 just exists. Don't bother about it. 5 times root 5 times root 5. What? Root 5 times root 5 gives us 5, no? The root gets removed. Root 5 times root 5 gives us 5. Now, this is not over. Don't just multiply and make it 15 because we can cancel this. Even if you multiply and make it 15, you can again cancel that. You can cancel. So in the numerator that is root 5, in the denominator that is 3. See, the new denominator was once irrational, but now it is rational. I hope it's very clear now because we did several examples. Yeah. Okay, great. Now I'm going to give you 3 questions and I'm going to give you some time to try them. Let's see. In page number 16 of the tube, you can try the questions 8. The 8th question is this. Question number 8. Question number 11. Question number 11 is 2 root 3 over 3 root 2. Question number 11. And then finally you can try question number 12. Question number 12 is 3 root 3 over 2 root 5. Yeah, these are the questions. I'll give you around 5 minutes. Give them a try. So when sending answers in the chat for an answer like this, you can type root 5 over 3, root 5 slash 3. Okay. Okay. So mute myself for a while. Okay, what about the answers? Have you got answers? Okay, I'm getting answers. Good. Okay, first one. Second one's answer is root 6 over 3. Let's see. Second one. Mm, yeah. Second one's answer. You're correct. Yeah. Let's see. The first one. The first one, even before starting the question, we can simplify these two. There's 1 3 in 3 and 9 3 is in 27. So the question begins as 9 over root 2. So we can multiply this by root 2. Na? Root 2. Root 2. So root 2 times root 2 is 2. 9 times root 2 is 9 root. So give me the answer. 9 root 2. The second one. So the first one. And the second one, so it's visible that we have to multiply the fraction by root 2. We are looking at the denominator. See, the 2 just exists. Root 3 times root 2 is root 6. The 3 exists here. Root 2 times root 2 is 2. The root gets removed. Now we can cancel this. So the answer is root 6 over 3. Correct. Root 6 over 6. And the final answer. This question, let's see. 3 root 3 over 2 root 5. So we have to multiply this by root 5. 3 exists. 3 root 3 into root 5 is root 15. Root 2 is here. Just 2 is here. Root 5 into root 5, the root gets removed and it's just 5. So the answer is 3 root 5 over 10. Yeah, and your answers are correct. So it's done. It's almost like it's done. But there's one question type, right? If they ask you something like this, I'll just ask you this question. Root 3 plus root 2. There's a question like 1 over root 3 plus root 2. What do you do? From which root do you multiply? What is the fraction you are taking to multiply this? Give it a guess. Just guess. So I'm getting answers like root 3 or root 6. But the truth is, you can try this at home. We have around 10 minutes more. So I'm going to tell you the answer. I'm going to tell you what to multiply with. It's not just root 6 or root 3, right? We have to multiply with. This is the reason why I taught you conjugates. Do you remember conjugates? What is the conjugate of root 2? Root 3 plus root 2. The conjugate of root 3 plus root 2 is root 3 minus root 2. Root 3 minus root 2. Right? The conjugate of root 3 plus root 2 is root 3 minus root. And you very well remember that. That's in our tube. There's a question in our tube even. Right? If you multiply root 3 plus root 2 by root 3 minus root 2, you will end up with the difference of 2 squares. You will end up with difference of 2 squares and the answer will be rational. But if you multiply by this by root 6 or multiply this by root 2, like you say, you're never going to end up with a rational denominator. Let's give it a try. So you are proposing, let's multiply it by root 6. Or else let's multiply it by root 3. Let's multiply and see. Let's see. 1 times root 6 is root 6. Right? Now, with this root 6, I have to multiply both the numbers. Now, this is the binomial. Root 3 times root 6 is root 18. Root 2 times root 6 is root 12. Right? We know these are entire surds. These are entire surds. So, 18, right? This like 18 can be written as 9 times 2. 9 times 2. 18 can be written as 9 times 2. 9 times 2. 12 can be written as 4 times 3. See, root 6 is there. 9 times 2 is 3 root 2. If you took 4 out, there is 2 root 3. Again, can you see the denominator has irrational numbers? The denominator is not yet rationalized, no? Do you understand that? Yeah. So if the fraction has binomial in the denominator, if the fraction has a binomial in the denominator, the only way we can solve it is by the conjugate. So the conjugate of root 3 plus root 2 is root 3 minus root. I'm going to multiply this by root 3 minus root. Now see, 1 times root 3 minus root 2 is just root 3 minus root 2. Root 2. Alright? Now, this thing. You can see that conjugates when multiplied, they create a difference of 2 squares. So we directly know the answer, root 3 minus root 2. So the answer for this is root 3 square minus root 2 square. So we know the square of root 3 square. The square of root 3 is just 3. The square of root 2 is just 2. This thing can stay the same. What is 3 minus 2? 3 minus 2 is 3 minus 2 is 1. 3 minus 2 is 1. So the denominator is 1. See, that's rational. So we don't even have to write the denominator. Because 1 as a denominator means the denominator is not even considered. See, the denominator is rationalized. Do you understand? Yeah. Great. So this is the end of the lesson. The final sum for today. I'm going to do the final sum for today. Now I'm going to give homeworks. And from the next month, we're going to start the second unit. That is indices and logarithms. Right? I'll give you the PDF and all. But this is the end of free sessions. So I'll create a new group and all. You can see the previous videos, real numbers 1, 2, and 3 in my YouTube channel. I'll put the link for that also. Okay. Let's first finish this. So the final question. Final question from our tube. Let's do a hard question, a somewhat hard question. Let's do the last question in the tube, not the last one. In page number 16, the 26th question. That's just 3 minus root 7 over 2 plus root 7. So like I said, we do not consider the numerators, we only consider the denominators. The denominators 2 plus root 7. So you know, you have to write the conjugate, no? 2 plus root 7, the conjugate is 2 minus root 7. So 2 minus root 7. So it will take some time because we have to multiply the numerators also. The first question, the numerator was just 1. Here, the numerator is a binomial. So I'll multiply this separately. I'll multiply this here. 3 minus root 7, 2 minus root 7. Let's multiply the numerator. First, we have to multiply by 3 now. So if you didn't understand, just tell me you didn't and stop me. I'll just repeat. 3 times 2. 3 times 2 is 6. 3 times root 7 is a number, this is a root. 3 times root 7 is 3 root 7. But it is minus, no? Plus and minus, no? Minus. The job of 3 is done. Now the job of root 7. Root 7 times 2, that is 2 root 7. Same thing, minus into plus. So it gives us minus. Root 7 times root 7, we know the root gets cancelled. The root gets removed. But minus and minus, minus into minus is minus into minus is plus. Now, carefully. 6, this is a positive number. 7, this is a positive number. This can be added. So 13. 13. See, like surge. Minus 3 minus 2. What is minus 3 minus 2? Minus 3 and minus 2 are similar signs. So we can add them. Minus 5. Minus 5 actually. Is the simplification of the numerator clear? The numerator is simplified now. 13 minus 5 root 7. The numerator is 13 minus 5 root 7. 13 minus 5 root 7. Solving the denominator is not a big deal because we know the conjugates when multiplied generate a difference of 2 square. So 2 plus root 7, 2 minus root 7. So we'll end up with 2 square minus root 7 square. So if you do not remember, you can watch the video, you can rewind and see. In the first question, there was root for both numbers. Here the root is only for 7. So here we have to take the square of 2. What is 2 square? What is the square of 2? Square of 2 is, yeah, correct. The square of 2 is 4. Okay? But the square of root 7 is just 7. Because he has a root now. So it becomes root of 49. Again, it's 7. So when this is simplified, the answer is minus 3. This is the answer. So see, the denominator has been rationalized. The denominator was irrational. It has been rationalized. So you can rewatch the videos. You can rewatch the steps, how I did that. You can slow it down and watch and come to a conclusion. You can do every question in the tube now. You can do all the questions. You can try them. And if you have any doubt, feel free to text message. Yeah, feel free to send a message of the question and ask. I'll clear the doubt for you. Okay. Hopefully we can meet next month. This is 31st now. So next month with a new lesson. Yeah, that's it for today. So I'm gonna end the class. Thank you.